Hi all, this video will cover the topics related to connection of LTI systems. As you know, LTI systems are expanded as linear time invariant system, the system which satisfy both linearity property and time invariant property. The LTI systems are connected in two ways. One is series connection and the second one is parallel connection. Series connection can also be called as cascaded connection. We will see one by one. Consider the series or cascade connection of two LTI system. The LTI system usually represented with its impulse response h of t. We will consider the two system, one with impulse response h1 of t and the other with impulse response h2 of t. These two systems are connected together and the first system receives an input x of t and it is processed by the system and the output of the system is y1 of t, and y1 of t is the input to the second system with impulse response h2 of t and it is processed and the output of the system is considered as y of t. So since it is an LTI system, the output is nothing but the convolution of the input and the impulse response of the system. Let us see the overall output y of t. The overall output y of t is nothing but the input to the second system y1 of t convolution with the impulse response of the system h2 of t. If you consider this diagram, then you know the y1 of t is nothing but the convolution of the input to the system, overall system x of t, and the impulse response of the first system h1 of t. So this can be expanded as x of t convolution h1 of t. Already we are having the term h2 of t in convolution with y1 of t. So the equation becomes like this. According to the associative law of the convolution, this can be rewritten as x of t convolution h1 of t convolution h2 of t. If you consider the overall impulse response of the system, let us consider that as h of t, then h of t can be found by convoluting the individual impulse response, that is h1 of t convolution h of t h2 of t. So this can be further simplified as x of t convolution h of t, where h of t is the overall impulse response, which is nothing but the convolution of individual impulse response of the two systems h1 of t and h2 of t. Just remember this result. Let us consider the other way of connecting two LTI systems. So here we will consider two systems, one with impulse response h1 of t and other with impulse response h2 of t. In parallel connection, both the systems will receive the same input, which is nothing but x of t, and the output of the two systems are combined or summed, and the sum is considered as the overall output of the system. Here we are having a adder for adding the individual response of the system. The sum is usually considered as the overall response of the system. The individual response, let us consider y1 of t and y2 of t. Then obviously the y of t is nothing but y1 of t and plus y2 of t. Let us consider the overall output. As you know, y of t equal to y1 of t and y2 of t, and y of t can be represented in other form in terms of the input and impulse responses, and it will be x of t convolution h1 of t. As you know, the y1 of t is the response of the first system, which is nothing but convolution of the input x of t and the impulse response h1 of t. Similarly, for the second system, it can be written as x of t convolution h2 of t. According to distributive property of convolution, this can be rewritten as x of t convolution h1 of t plus h2 of t. If you want to find the overall impulse response for this system, let us consider the overall impulse response as h of t, and this can be mentioned as x of t h of t, where h of t is the overall impulse response of the two systems connected in parallel, which is nothing but h1 of t plus h2 of